Hello, chemistry students. So I'm going to go over dimensional analysis with you, and we're going to try to get through this. This is a very important thing, and we'll use this skill multiple times throughout this school year. So let's go through and talk about what it is. So dimensional analysis is all about converting from one unit to another, but you're not going to use a formula necessarily to do so. So we're changing from one dimension or one unit to another in dimensional analysis. Okay, so we can use a relationship between any two known units, and those are called conversion factors. An example of a conversion factor is 60 minutes equals 1 hour. So there's a couple of ways you can state that. So as conversion factors, we'll take this 1 hour equals 60 minutes, and we could either use it as 1 hour divided by 60 minutes or 60 minutes divided by 1 hour. And if you're a math nerd or whatever, you probably realize that when you have two quantities that are equal, like let's say x equals y, so 1 hour equals 60 minutes. All right, so like if we were wanting to convert from minutes to hours, we would use this one. If we were wanting to convert from hours to minutes, we would use this one. Basically, this is saying if you have minutes, you want to go to hours, you divide by 60. If you're at hours and you want to go to minutes, then you multiply by 60. And I'll show you how that works in a lot more detail as we go on. Okay, so just kind of to know where we're at here in the math department. So we talked about using formulas like the density formula earlier. We'll learn specific heat and lots of other formulas later on. Right, this is a different category. Dimensional analysis is going to be about converting from one thing to another. All right, so let's continue on. All right, so some other conversion factors we could look at here. 1 mile equals 5,280 feet. You could use it both ways here. Or 11 pounds equals 5 kilograms. You could use both of those, this one way or the other. And basically, you're just flipping it so that you could convert the opposite way from whatever you were trying to do. Like this one would be for going from kilograms to pounds. This one would be going from pounds to kilograms. And, if you had like 15 pounds and you want to convert to kilograms, then you would basically multiply by 5 and divide by 11, and that would give you your answer in kilograms. Okay, so the structure of this, we're going to start off with, some people call these train tracks. It kind of bothers me because train tracks have, two rails for the train to ride on. But anyways, these do kind of get longer. Maybe it's a train track, like on a map or something. But anyways, you'll draw a line and then the little cross things. And this is going to help you structure your dimensional analysis setup. So you're going to be given some number with a unit to start with. And you'll put that known number, and you always start with the known number and unit here to begin with. And the top left. And then in order to cancel that known unit out, you need to have a conversion that has that known unit in it here. And then something that known unit is equal to up here. And you need to have the appropriate numerical quantities here, like 1,000 grams equals 1 kilogram or something like that. All right, and we're still going to do UKPS as we work through these problems. All right, so you're always going to begin with the known. So unknown in this problem is how many centimeters. The known is 4 meters. And our plan to get from there to there is going to be to use this conversion. 1 meter equals 100 centimeters. All right, so now we're going to solve, and that means, like we said up here, we're going to start with the known. So the thing that the quantity we know, And then we will convert that to the thing that we don't know. Now, we want meters to cancel out, so meters will need to go on the bottom. And then we need a conversion to get from meters to the quantity that we want. So 1 meter equals 100 centimeters. These need to be equal to each other. All right. So once you do that, notice the meters cancel out because this meters is in the numerator and this meters is in the denominator. Basically, these are like fractions, and we're multiplying them. So the lines are kind of like parentheses, and we're just doing math here. So numerator of a fraction, denominator of a fraction. So we'll multiply the things that are on the top, multiply the things that are on the bottom, if there's more than one thing, and then do the top divided by the bottom. All right, so that's what that says here. Multiply across the row and divide by each section on the bottom. And so that's going to give us 4 times 100 divided by 1, and that will be 400 centimeters as your final answer. All right, here's another one. We're going to convert meters to kilometers. All right, so we know the meters. We do not know the kilometers, so the unknown is the kilometers. And our plan, we would need to know that 1 kilometer equals 1,000 meters. All right, so when we solve, always start with the known. And then we need to match those units up. So we need meters on the bottom to cancel these meters out. And then we know that there's 1,000 meters in 1 kilometer. Meters cancels out as we wanted it to. Multiply across the top, divide by the bottom. That'll give us 0.01 kilometers. All right, another application for that, we could apply this to taking a trip by car. Let's see what the gas price is looking like compared to the current. We've been both above and below in the time that I've been using this PowerPoint. So first we probably need to know where are we going, how many miles is it to get there. And then we'd probably also need to think about, well, what type of car, how many miles per gallon are we getting in the car? And then how much does it cost per gallon? So how much does it cost to drive to Myrtle Beach? So our known here is going to be 1 trip to Myrtle Beach, and then we're going to have a few conversions here. So 1 trip to Myrtle Beach, 250 miles. And we're working with a gas price of $3.10 per gallon of gas, and we're driving a car that gets 25 miles per gallon. And that's, you hear me saying that per. So when we're talking about units where there's a per, like if it's 25 miles per gallon, that's 25 miles in one, or for each gallon of gas you burn. All right. So let's work our way through this. So we're going to start with the known, like always. And then we know that that's equal to 250 miles. 1 trip to Myrtle Beach is equal to 250 miles. And then the 25 miles equals 1 gallon. So 25 miles on the bottom here, that'll cancel out that miles. And then 1 gallon. By the way, this would be really messed up if you did 25 over 1. You wouldn't get the right answer. And then we need to get from gallons to dollars. So we'll use our last conversion here and put, we got 1 gallon, and that's equal to $3.10. So whatever number, if this was 2 gallons equals 620, we could use 2 and 620, and that would be fine too. But the ratio of these needs to be maintained, or in other words, just pull, if this is 1 gallon, and this is 310, you just pull those numbers and put them where they go. All right, so all the units cancel out appropriately, and we would enter this In fact, what I'm going to tell you to do with this is 250 times 310. You can put the ones in there if you want to, so multiply the top. And I'll get you to multiply the bottom. 1 times 25 times 1. Do the top divided by the bottom in your calculator. If you happen to be working with a cell phone calculator, what's shown on the screen here is probably fine. But if you happen to be working with like a TI Inspire, if you hit the divide button a bunch of times, it's going to do crazy stuff. If you're on a TI-83, this is great. That would work fine. All right. And when you do all that, you get $31. Not too bad for a beach trip. Sounding pretty good to me at the moment. And gas is cheaper than that right now. Okay. So these metric prefixes, I've used a few of them so far. Let's go over those and talk about what the different ones are. We're going to use like kilo and centa and milli the most of any of the prefixes that we use. And I'm just going to ask you to refer back to this and get them if you need to. So like, if I say a kilometer, that means that I have 1,000 meters. Or if I say a kiloliter, then I have 1,000 liters. I think I said meters the first time. Anyways, so a kilometer is 1,000 meters. A kiloliter is 1,000 liters. Anything you put there, a kilogram is 1,000 grams. And that would work for mega or giga or whatever. And you probably see mega and giga quite frequently when you're talking about megabytes or gigabytes. And it's pretty important to know the difference between those two, because there's a gigabyte is 1,000 times bigger than a megabyte. And it used to be that internet speed was measured in KBS, kilobytes per second. And now it's in megabytes per second. Literally, the internet is 1,000 times faster now than the dial-up connection that I used to have. And we're working our way toward gigabit internet, and some places already have that available. So, maybe when y'all get out of, when y'all are my age, maybe you'll look at this and be like, wow, we've got gigabit internet. That's 1,000 times faster than my internet used to be. So, there you go. All right, the ones that are smaller than the base unit. So we have deci, centi, milli, micro, nano, pico. Oh, too far. And let's see. So what this means is that if you have a meter, that's equal to 100 centimeters. So a centimeter is 1/100th of a meter. And a millimeter is 1/1000th of a meter. And let's see, so like here, as a conversion factor, 1 meter equals 1,000 millimeters, or 1 liter equals 1,000 milliliters. All right, so review of some of the smaller ones and kind of putting them on the same screen. So this is telling, the base unit is kind of here in the middle, so it would take 1,000 of the base unit to make a kilo of the base unit, and it would take 10 of the deci of the, like decigram, take 10 decigrams to make a gram. All right, so it looks like I'm getting into the sample problems here. I'm going to stop recording and come back and make a second video showing you some more practice problems.